Welcome Year 7s to another lesson. In this lesson, we're going to be talking about number patterns. Always remember, you shouldn't just be watching this video, you should be taking down notes as well. And I want to see those notes to double check that you're actually doing it. Now, what are our learning objectives? Our learning objectives are to understand what a number pattern or number sequence is, to be able to describe a pattern where there is a common difference, in brackets added or subtracted, to be able to describe a pattern where there is a common ratio, multiplied or divided, and finally to be able to find terms in a number pattern with a common difference or ratio. Okay, that's a lot of information. Hopefully we're able to do all of this by the end of the lesson. So let's begin by talking about some key ideas. So, number patterns are also known as sequences, and each number in a sequence is called a term. Now, we shouldn't get confused with our algebraic terms. Each number pattern has a particular starting number, and terms are generated by following a particular rule. So there's a lot of information there, and it's always easier to understand things when we have an example. So here's our example. Here's our number sequence. So our number sequence is 3, 6, 9, 12, 15. That's our sequence or number pattern, if you'd like to say it that way. Now, what is a term? Well, a term is just 3. A term is 6. A term is 9. A term is 12. So all of these are terms. So I have 1, 2, 3, 4, 5 terms here. 3 is a term, 6 is a term, 9 is a term, 12 is a term, 15 is a term. I have a starting number. My starting number is 3. And now, most importantly, we need to know how terms are generated by following a particular rule. Now, hopefully by looking at this, you can immediately identify what the pattern is. So my pattern is, well, 3 to 6. Well, how do I get from 3 to 6? I plus 3. How do I get from 6 to 9? I plus 3. How do I get from 9 to 12? I plus 3. How do I get to 12 to 15? I plus 3. So the way that I'm generating new terms is by plussing 3. So if I was asked to generate one more term, I'm going to go 15 plus 3 is 18. And that's how I would do it. Let's keep reading to get some more information. So I'm going to grab my highlighter here. The rule that creates the sequence number pattern is based on one of the followings: addition or subtraction, or division and multiplication. So when it's addition or subtraction, what we say is that there's a common difference. So terms will increase or decrease by a constant amount. And as you can see here, it's quite clear that we have a common difference. So in this instance, we're adding, so we're going to have a common difference. And if I was to grab a pen here and say, well, what is my common difference? Well, if I just go 6 minus 3, so 6 minus 3, I'm going to get 3. If I went 15 minus 12, 15 minus 12, I'm going to get 3. If I went 18 minus 15, I'm going to get 3. So there's that common difference between each of my terms of 3. So that's what it means when it says common difference. Now, common ratio is when we divide or multiply by a constant amount, and we're going to be seeing an example of that soon. So let's now come over here and do a few examples together. So this type of question, where we're asked to find the next 3 terms, this is what you're going to see when you're doing your exercises. So this is where you really have to become familiar with it. Okay, so let's look here. So we need to find the next 3 terms, and we have 2, 6, 10, 14. Now, hopefully you can immediately look at this and say, well, I obviously have a common difference, and my common difference is plussing 4. So my common difference is 4. And the reason why we know that is because, well, if I have 6 minus 2, 6 minus 2, that's going to be equal to 4. Or if I had 14 minus 10, 14 minus 10 is going to be 4. So I have a common difference. That's an ugly N. Common difference. A common difference of 4. Now, in your exercise, you just need to be able to write out what the next ones are going to be. So if we're plussing 4 each time, so I'm going to be plussing 4, I'm going to be plussing 4, I'm going to be plussing 4. So that means I'm going to get 14 plus 4 is 18, 18 plus 4 is 22, 22 plus 4 is 26. And just like that, I was able to answer my question. Now, if you don't want to do all this subtraction business, if you just immediately recognize that you're plussing 4 every time, go right ahead and just put in your answers. So I'm just kind of giving you more than one technique. So if you're a bit confused, you might think about subtracting them and seeing if you're going to get a common difference each time. Let's go over here. And okay, this is one of the instances where, again, you just might be able to look at it and go, well, 2 to 6, that's obviously timesing by 3. And that makes sense because over here I'm timesing by 3 as well. So immediately I see that I'm timesing by 3 each time. So 2 times 3 is 6, 6 times 3 is 18. So to get my next one, I'm just going to times by 3. I'm going to times by 3. And I'm going to times, wait for it, by 3. So that means I can fill in my numbers here. 18 by 3 is 54. 54 by 3 is 162. And 162 by 3 is a 486. If you wanted to approach it in this way, so let's say you're looking at it and you couldn't quite figure out what how it's going up by, you could say, well, if I go 18 divided by 6, if I could read the numbers, that would be helpful, wouldn't it? 18 divided by 6, that's 3. If I go 6 divided by 2, that's 3. So it looks like I have a common difference. Common ratio, not a common difference, a common ratio of 3. I have that common ratio of 3. And that's because when I take the ratio of these numbers, or when I divide them from each other, so 18 divided by 6 is 3, 6 divided by 2 is 3. If I went 486 divided by 162, I'm going to get 3. So hopefully you're comfortable with that. Let's now continue on. I have 99, 92, 85, 78. Again, you might be a bit confused about what's going on here. You might be able to immediately recognize the difference, but let's try finding if there's a difference between these. So 99 subtract 92, that's 7. So too, 85 subtract 78, 85 subtract 78, what's that going to be? It's going to be 7 again. So it's quite clear that I'm decreasing by a certain number here, and that number is 7. So I'm subtracting 7 each time. Each time I'm subtracting 7. Let me continue. Subtract 7, subtract 7, subtract 7. I'm going to grab my blue. 78 minus 7 is 71. 71 subtract 7 is going to be 64. And 64 subtract 7 is going to be 57. So here I have a common difference. I have a common difference. So look, I have a common difference, common ratio. Here I have a common difference. It takes me so long to write. Common difference of 7. Let's now come to our last one. So we have 256, 128, 64, and 32. Now you might be thinking, oh my goodness, these numbers are so big, how do I do this? Well, let's just look at the smaller numbers first. How do I get from 64 to 32? Well, it's obviously dividing by 2. And then I can come over here and go, well, that makes sense because 128 divided by 2 is going to give me 64, and 256 divided by 2 is going to give me 128. So now I'm just going to continue this along to finish off what my pattern is going to be. Grab my blue pen. 32 divided by 2 is 16, then 8, then 4. Again, if you're thinking, oh no, I don't think I would be able to figure out what this divided by 2 is, what you can do is find the ratio of them. So if I went 32 divided by 64, 32 divided by 64, that's going to be 1 over 2. Just to prove that to you, if I went 4 over 8, 4 over 8, that's going to be 1/2. So it's quite clear here that I have a common ratio of 1/2. Now, remember that timesing something by 1/2 is the same thing as dividing it by 2. So we say that there's a common ratio of 1/2. But I also want you to remember that the most important thing is understanding how to find the pattern and then filling in your blank spots. If you can fill in these blank spots, that's all you need to do. So just make sure you're very comfortable with filling in these blank spots. Okay, let's now continue on. Now we're going to go through some challenging questions. So here we have 1, 3, 6, 10, 15. I want you to pause the video and see if you can figure out what the pattern is here. All right, so how did you go with it? Let's now have a look for ourselves. So hopefully what you're able to recognize, oops, if my pen wants to work with me, let's get rid of that line, is from here to here, I am plussing 2. From here to here, I'm plussing 3. From here to here, I'm plussing 4. From here to here, I'm plussing 5. Hopefully you can see what's happening here. 2, 3, 4, 5. I'm going up by 1 each time. So this is going to be plussing 6. This is going to be plussing 7. This is going to be plussing 8. So if I was to fill them out here, 15 plus 6 is going to be, wait for my pen to kick in, there it is, 21. 21 plus 7 is going to be 28, and 28 plus 8 is going to be 36. Now, just so you can write a little explanation to the side here, I want you to write this. The difference increases by 1 each time. Let's now continue here. Now, for this one, I'm actually not going to put in my arrows. Hopefully you can recognize something important about each of these numbers, and that is that they are squared numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So that means up here, what I'm going to get, I'm going to have 5 squared, which is 25, 6 squared, which is 36, and 7 squared, which is 49. Let's now put in a little bit of an explanation. So this is what I want you to write here to the side. This is a pattern of squared numbers. Now, this one down here, this is where it gets a little bit tricky. So what's going on here? So again, pause the video and see how you go. All right, so this question really hopefully, to get this answer, you had to take a step back. So hopefully you realize there wasn't a common difference between each of these terms, because 2 to 8, well, I'm plussing 6, but then I'm subtracting 4, then I'm plussing 3, then I'm subtracting 1, then I'm staying the same. What on earth is going on here? And again, you had to take a step back and say, look here, I have 2, I have 4, I have 6. So obviously what's going on is that I'm skipping from here to here, I'm plussing 2. From here to here, I'm plussing 2, which means from here to here, I'll be plussing 2. And from here to here, I'll be plussing 2. So that means what I'm going to get is 6 plus 2. Let me get my blue pen here. 6 plus 2, that's going to be, wait for my pen to kick in here, 8. 8 plus 2 is 10. Now, let's look at our other one here. So the things that I haven't highlighted, 8, 7, 6. Hopefully you can hear that counting going on. Obviously what's happening here is that I'm subtracting 1 each time. I'm subtracting 1 each time. Oh, I've done this in the wrong color, but we're going to have to keep on going. So I'm subtracting 1 each time, which means I'm going to get 6 minus 1, which is going to be 5. So 8, 5, 10 would be my next numbers. And if you just wanted to prove that to yourself, you could say 2, 4, 6, 8, 10, and then 8, 7, 6, 5. Now, how would you describe this pattern? So you could come over here, and this is how you could describe it. The odd numbered terms increase by 2, and the even numbered terms decrease by 1. So what they mean by that, or what I mean by that when I say that, is that this is term 1, this is term 2, this is term 3, this is term 4, this is term 5, this is term 6. So if we look at our odd ones, 1, 3, 5, they're the ones that are plussing by 2. If we look at our even ones, 2, 4, 6, they're minusing by 1. So that's what that explanation means there. Let's now go on to our final slide right here, which is, again, just a bit of something special that I thought you might enjoy. What is the most famous sequence? So what is this pattern right here? So I'm going to give you a second to think about it. Maybe you want to pause the video and see if you can find a pattern. Then I'm going to tell you. All right, now I'm going to tell you. So what this is, well, let's first talk about what the pattern is. If I go 1 plus 1, that's 2. If I go 1 plus 2, that's 3. If I go 2 plus 3, that's 5. If I go 3 plus 5, that's 8. If I go 5 plus 8, that's 13. If I go 8 plus 13, what's that going to be? It's going to be 21. And 13 plus 21, that's going to be 34. So that's how the pattern works. You're plussing together the two preceding ones. And what we call this is the Fibonacci sequence. So each term is the sum of the two preceding ones. If you want to learn more about this, I'm going to show you a video very soon. And basically, the reason why this is so famous is because it appears in nature a lot of the time. So if you want to learn more about this, click on this video right here and you will learn why this sequence appears in nature. Let's now review what we've learned in this lesson. So our learning objectives were to understand what a number pattern or number sequences is. Hopefully by the end of this lesson, you're able to give that a big tick. You also had to be able to describe a pattern where there is a common difference. one when there's a common ratio, and finally to be able to find terms in a number pattern with a common difference or ratio. Hopefully by the end of this lesson, you're able to do all those things and you feel confident about number patterns.